Coming up on This Week in Radio Tech, supply chain problems from the grocery store to ordering things online to trying to get your broadcast equipment. It has been a problem. And what are we doing about it? What are manufacturers doing about it? And what are the root causes, and can they be mitigated? Well, Scott Stiefel, the new co-CEO at the Telos Alliance and still the COO at Telos Alliance, has been dealing with this for 2 years now, and he's got some great answers and some good ideas for us. Coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics, with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower back there. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. So glad to be here. It's been a beautiful day in Nashville. Little clouds now, but it got up to about 60 degrees here. Here I was stuck in the office all day. Oh, well, it's work. Hey, but thanks to Telos for giving me about an hour every week to take care of this show and bring you some interesting guests. Right now, I have an interesting co-host. He is also in his basement abode, as I am, Chris Tarr in Mukwonago. Hey, Chris, good to see you.
Hey there, Kirk. Yeah, I've heard myself being described as interesting, but I don't know if that's a compliment or not. So yeah, not 60 degrees here, but a nice day. And yeah, it's been one of the unusual office days for me today.
I see a new piece of equipment adorning your studio.
Yes, I've got the Shure Mv7 microphone. I saw, after hearing Barry's microphone last week and seeing it and looking at the features, I decided I had to get one. So I've been, doing some voice work with it, and I like it a lot. It's a great microphone.
It's cool because it's got both a dynamic, XLR output and a USB connection as well. So it's got both country and Western connection.
It does, and it works with the Shure Motive app, so it's got a little bit of built-in mic processing. You can go really heavy on it. I'm going pretty light on it, but it's got compression limiting, everything else if you use the USB section. But then, of course, it's got XLR, so I can hook up to my Focusrite or whatever you want to do for a voice processor. So it's very versatile that way. And like I say, it sounds really, really good. I've been very pleased with some of the commercials and things that I've voiced this week with it.
Chris, I'm going to keep our guest secret for another 30, 40 seconds or so. We're going to hear from our friends at Nautel, where they do Transmission Talk Tuesdays, this terrific roundtable. Engineers love to participate in this. This month, it's all been about IT. But right now, we're going to see a quick clip, a quick idea from Jeff Welton at Nautel.
Today, every device that can be talked to is talked to. And we basically meet with manufacturers now and say, if it doesn't speak SNMP and it's in the air chain, we really can't even look at it. And we kind of take a hard stance on that because of our size and the need to not be dispatching engineers to be, trying to find out if it's just something needs to be reset. The cost involved in that is astronomical. In fact, Nautel's got so many amazing readings that you can get through SNMP. The MIB is just phenomenal. And so if we want to go crazy, we'll have the entire thing set up in the Relio to monitor every fan, every module, every temperature.
See that website there, nautel.com/webinars? That's where you can go to register for the next Transmission Talk Tuesday. It'll be this coming Tuesday. Jeff Welton's your host, and he always has some terrific guests. This whole month, it's been about IT in broadcasting and what you need to know. I also saw Josh Bone in the clip right there. Josh is also a sponsor of our show. We'll hear from Josh's company in just a few minutes. Okay, let's bring our guest in. It is, I always talk really nice about him. He's a good guy anyway. I would anyway. It is a guy who's kind of my boss's boss's boss, right? Scott Stiefel, welcome into This Week in Radio Tech. How you doing?
Doing very well. It's good to see you again, Kirk. How are you?
It's good to see you. And Scott, you and I met, 20 years ago when I started working for the company. And we're going to get into some of your background there. But too, let's get a little announcement out of the way. I have known you in the role of a development engineer, and I'm not sure what all your titles have been, but for the last few years, I've known you as our chief operating officer, and that means you get all the headaches and solve them. but you've also been rolled into a new role. You want to tell us about that?
Yeah, so as of about 2 weeks ago, I have been named the co-chief executive officer of Telos, or co-CEO, working alongside Tom Swiderski, who's been with our organization now for, I guess about 4 years now. So it's really quite an honor to be in this position. As you said, I've been with the company since 1994, more or less right out of college. Worked as a hardware engineer, embedded systems engineer, project manager, program manager. Got a partial lobotomy when I got my MBA and moved into the operations side of the business, and was an operations manager for a few years. And I actually took a hiatus from Telos. I went to go work for a company called Viasat Incorporated. Some of you may have heard of that. A big satellite equipment provider out on the West Coast, but they purchased a company here in Cleveland. So I did that gig for about 6 years, still on the operations side of the business, but learned an awful lot about satellite communication and high-speed communication, development of ASICs, semiconductor chips. But my true calling came, and I came back to Telos in 2014, talked with Frank and as the chief operating officer. That was the position offered to me. And then, 2 weeks ago, was offered the position to step up into the co-CEO role here, sort of at the top of the company. And it's just been an amazing journey to be with a company this long, see it grow from the 19 people it was when I joined the company to over 120 worldwide at this point. And, big shoes to fill. People like Steve Church and Frank Foti, Mike Dosh, and now Tom Swiderski have all held the role of CEO of Telos, and it's really an honor to step into that role now for myself.
You just went through a number of people's names. Some of them are some of the literally the best people in broadcasting, and all of them have just been fantastic business minds as well. We're gonna circle back on that in a minute. I want to relate your experience back to something that almost all of our viewers and listeners know about. You had a hand in designing part of the Telos Zephyr, the ISDN codec, and it was part of the codec that really set the Zephyr apart from the other ISDN codecs that were on the market back in the early and mid 1990s. Why don't you tell us what you did for the Zephyr?
Yeah, so when I first got hired by Steve, came into the building and he said, "Okay, I got your first project. I want you to design the ISDN card, plug-in card for the Telos Zephyr." And I had two questions: what's a Zephyr and what is ISDN? So I had a lot of learning to do. I didn't come from the broadcast industry. In fact, I had spent my first 2 years after college working for a company that made pacemakers and implantable defibrillators. So a far cry from broadcast and ISDN and communication. So dove right in. But that ISDN card, while it seems like a trivial thing, design a card for this big box that does all these wonderful things. First product to use MP3 in a commercial environment. But it was part of the genius of Steve, because what it did is it put everything you needed to use the box inside the box. And that's what really set it apart from most of the competition. Is you had this box, it had a dial pad on the front, it had an LCD display, not a bunch of toggle switches. You didn't need cables to hook it up to other equipment. You just plugged your ISDN telephone line right into the back of the Zephyr once this card was developed, and you punch in the phone number of a Zephyr on the other end, and it just connected end to end. And it's always overblown to compare yourself to companies like Apple or people like Steve Jobs, but it was that kind of mentality that Steve Church had. How do you take something that's really, really complex, but make it extremely simple and easy to use so that the people who are using the equipment can focus on why they're using the equipment, not the actual equipment itself? So that was my introduction to Telos, and just designing this one piece, but that really was something that changed the product itself and set it apart from the other products that were doing similar functions.
So, Scott, you and I, we met virtually over the ISDN Zephyr because, of course, I was a Zephyr user. Even though I was in a small market in Mississippi, we used a Zephyr to get our morning show up to our headquarters. And at the same time, Chris Tarr, the co-host right here on the show, I met Chris Tarr in part because of Zephyrs. I met Chris Tarr on September 11th, 2001, that fateful day. And Chris was busy connecting his radio stations, a bunch of them around the Chicagoland area with ISDN. Don't you remember that, Chris?
I do. And, it's funny. I remember that. I remember SPIDs and I remember Ready are the two, all the things I took away from that. But it's amazing that box really opened up a new world for broadcast. About that same year, maybe the year after, Chicagoland Speedway opened, NASCAR track in Joliet, which is where I was at the time. And we were able to set up a remote studio to cover the races. And, we had a trailer, we had ISDN lines put in, and, we put the boxes in and we were good to go. We actually simulcast that on a couple of radio stations too. So, it really, and you mentioned it, that was one of Steve's brilliant things is, he always took these devices and went, okay, first of all, how can we use them in radio? And second of all, how can we use them and make them simple enough and rugged enough that we could take them out and use them elsewhere? And, those ISDN boxes for their time were just, the Zephyrs were amazing. And it is interesting to look back now and go, nobody uses that anymore, but back then that was really the only way to do it. So, it really, it did a lot. So it was funny that the day I met Kirk, I was running around dialing up ISDN boxes all over the place. And I had, outputs of one Zephyr into the input of another Zephyr that was going, somewhere else. And, I must have had probably, 5 or 6 Zephyrs connected in one form or another that day.
There's Chris with his cascading algorithms.
Yeah. Hey, I didn't say it sounded perfect, but it was there.
You got news on the air of that fateful day. Well, we're actually gathered here today to talk about something a bit different because back in the early mid 90s, and actually I met Chris in 2001, obviously, but those were kind of the good old days when I don't know if we had supply chain problems like we do today. And actually that's why Scott Stiefel, the new co-CEO, and Scott, are you keeping the COO title for a while? Or are we going to force somebody else into that job?
Yeah, that remains to be seen at this point. Right now, I'm kind of wearing 2 hats at this point. So, in fact, I spent a lot of time this week doing a lot of the things that I was doing as COO. So, and that'll probably continue given what we're going to talk about today, right? It's really been all hands on deck at Telos, like every other manufacturing company.
Hey, your family's got to be happy with you bringing home 2 salaries. That must be fantastic, right? I think.
If only.
That's how that works, right? So, we brought you on to talk about supply chain because supply chain has certainly affected everybody and everything. Sometimes you go to the store. I went to the Kroger store where I normally go shopping at. They have no cream cheese. Now, I'm not usually a big cream cheese eater, but we had some recipes last weekend that we were making. We needed cream cheese. They had no cream cheese. Not the store brand, not the Kraft brand, not the Philadelphia brand, nothing. They had no cream cheese. I think they had the jalapeno cream cheese and it wasn't going to go well on whatever we were cooking. So supply chain has been a problem for everybody. And that's what we're here to talk about. Let me do a time check here. Okay, it's 13 after the hour. So, Scott, why don't you introduce us to that before we take our next break? Tell us about how, what's been kind of, I don't know, however you want to introduce supply chain into our business, which involves electronics, getting electronics there on time and getting products built. How would you open up that conversation, Scott?
Well, I guess first, let's just make sure that everybody's speaking the same language here. Everybody throws around the term supply chain, but what is a supply chain, right? So it's kind of what it says. It's a chain of people, customers, businesses, activities that form the ability to take goods from somewhere, turn them into something, and deliver them to where they need to be at some other point, right? So in our business, you're talking about a supply chain would be a broadcaster. If you work a step backwards, you'd be talking about the distributor from whence they buy their products, and then the manufacturer that produces those products, the contract manufacturer that might make the circuit boards or the sheet metal vendor that might make the chassis that the OEM or the manufacturer uses to make the products. If you work backwards, then you're looking at the steel mills that make the steel for the chassis, or you're talking about the semiconductor fabs that make the chips, that supply the contract manufacturers, that build the boards that go to the manufacturers, and on and on and on. So that entire chain, end to end, that's the supply chain. And if you think about it, one of the things we'll talk about today is the longer that chain is and the more pieces that you have in that chain and the more time that's involved in taking something to get from one end to the other, that forms a fairly unstable system. A lot of the people involved in supply chain and operations management like to talk about the bullwhip effect. So if you imagine the supply chain as a long bullwhip, and it sits there and oscillates nicely and smoothly if you're not perturbing it, but when you have sudden changes at either end, you know exactly what happens at a bullwhip. So something small and sudden happening at one end, maybe a shortage of semiconductors coming out of the fabs, that oscillates, and then when you get to the far end, for instance, to the broadcasters, what you see are these massive shortages. You see long delays in delivery. So that's what we're going to talk about today, is what causes these oscillations, what are the things that are perturbing the system right now, what's happening in the world, and what are people like Telos doing to smooth this out or ameliorate these problems, and when might this end? So, hopefully that gives you some idea of, the breadth of what we can talk about today, just in terms of our industry, right?
Yeah.
And then you look any other supply chain, right? We talked about the shortage of, things in the grocery store, like toilet paper, for instance, at the beginning of COVID. What caused that? That's a totally different supply chain than what we're talking about here, where we're manufacturing electronic equipment. But the basic principles still hold. And that's true of any supply chain in the world.
I live not too far from a couple of automobile manufacturing plants. Nissan is down the road from me, and there's the GM factory where they used to make Saturns. I'm not sure what they make there now, something else. And, you hear stories of cars being made. They'll put a chip in the car that they only have a few of, drive it out to the big, huge parking lot, park the car there, pull the chip out, because they ain't got very many of them, run that back to the factory, and go drive the next one out and park it.
Right.
And they can't deliver these cars until they get another supply of the chips. So we're going to talk about that coming up. It's This Week in Radio Tech, episode 582. We've been going strong for about 12 years here. Scott Stiefel, the new co-COO at Telos Alliance, is our guest, talking about supply chain and what Telos, and this might apply to other broadcast equipment manufacturers as well, but certainly what Telos Alliance has done, working very full-time to try to ameliorate, that's a hard word to say, these troubles too. I was just taking account. Our show is brought to you in part by Angry Audio, and Angry Audio bought the whole studio hub, everything, lock, stock, and barrel, I guess the expression is. And one of the items that you can get from Angry Audio now is this studio hub headphone amplifier. This is the one that fits into a J box, an ordinary box, uses the Decora front of it. It's got that size, so there's all kinds of stuff it's compatible with. And I just counted, there's about 64 components that you have to make this thing. So if Angry Audio, and I know they make them, they assemble these things themselves. If they have 62 of these 64 components, they can't ship this. They have to have all 64 of the components that go in here, plus the anti-static sleeving that goes on it, and the one sheet manual, the box. They got to have everything. So they got to have about 65 or 70 items in order to ship this thing. And so Scott's going to be telling us about that. Now, you can get these. They do have them. They are able to get all 65 components. But another example is this one right here. This is their Headphone Gizmo. And I love this thing because it, Chris Tarr, you know what I say, you won't snag what on this? You won't snag your pantyhose on this one, because it's got a nice smooth finish to it. You hang this, or you screw this up underneath your audio console table, right? And you can plug your headphones right into it. It has both size headphone jacks. It's got the 1/4 inch and the 3.5 millimeter size. And on the back, this is the key to it, it's got this Studio Hub standard for power distribution and audio distribution. Yes, it's on an RJ45 jack, but it's not Ethernet. It is a standard analog audio, left and right, and power. And one power supply will power 3 of these. You can also set them on the table upside down like this. They have little rubber feet already built into them, so they'll sit right there on the table. Now, once you've plugged in, remember that those silly talent, they can wear those headphones and they can walk away with the headphones still on. And what are you going to do? Use this right here, the Headphone Disconnector. You insert this in line with their headphones, and when they walk away, snap. It just comes right apart with a MagSafe-like connection right there. And it goes right back together. Left and right stay proper because it won't go backwards. Look at this. You try to put it together backwards and the magnets won't let it. That's the Headphone Disconnector. It comes in 1/4" size and also 3.5 millimeter size from Angry Audio. Check them out with your favorite dealer. Hey, our show is also brought to you. Oh, there it is right there. angryaudio.com. They got all kinds of cool gadgets there. Our show is also brought to you in part by the folks at Max Connect Wireless. Let's hear from Gary Morrill.
I'm Gary Morrill, Midwest Regional Director of Engineering for Alpha Media. When I first spoke with Josh Bone about Max Connect, he told me they'd work great for remote transmitter sites where connectivity was a challenge. And he's absolutely right. We even have sites where we're using this as a backup to our STL using Max Connect's dual carrier option, and it works perfectly. We also have times where we need to be able to get out to a venue where it's kind of challenging because everybody and his brother is trying to stream video at the same time, like at a big sporting event. And you know what? Our data gets through every time because it's prioritized packet data. It works for us. It'll work for you. Max Connect. Check it out.
He's got the one from Cradle Point right there. That's one that Geary had. There's also one from Pepwave, and it really doesn't matter the 4G LTE modem. That's not the key. The key is the SIM card that goes inside, because Josh Bone at Max Connect Wireless has made arrangements with Verizon, AT&T, Sprint, T-Mobile to get you prioritized data on those carriers' networks. So you get data that goes ahead of everybody else's except first responders. And like Gary said, you get a fixed IP address with Max Connect Wireless. Check them out on the web. There's the funny name, MAXXKONNECT, maxconnect.com, maxconnect.com. Broadcasters are loving it for remote broadcasts from stadiums, studios, from parades, and also from transmitter sites because of the fixed IP address. Really cool. Hey, okay, it's This Week in Radio Tech. Scott Stiefel is along. He's the co-CEO of Telos Alliance, so he's my boss's boss's boss. Also, Chris Tarr is here. And Scott, we're talking about supply chain, how that affects people's ability to receive equipment in a timely manner, or if they got to wait. And I think we're going to get right into some root causes. Pandemic, you were talking about that. Just-in-time manufacturing, wild swings in demand. Start us off there, if you would.
Okay, so we were talking about this bullwhip effect, right? So that's the thing that causes these huge oscillations in the supply chain. And if you picture the bullwhip at the peak, you've got oversupply, you've got waste. If you've got a trough, in the oscillation, that's where you've got a shortage somewhere in the supply chain. So what causes all that? So, one of the things in manufacturing in the world in the past 20 or 30 years, or maybe pushing 40 years, is this idea of just-in-time manufacturing, or JIT, right? You've probably heard a lot of people talk about that. Kind of came out of the Japanese way of doing manufacturing to cut waste. So perversely, while that has made manufacturing much more efficient and saved money because you don't have inventory piling up all over the place, you have the stuff you need, where you need it, when you need it, which is the kind of the philosophy behind just-in-time, and you tighten up the supply chain, you do eliminate a lot of cost, waste. You don't end up with obsolete parts sitting around because you haven't stockpiled inventory. But one of the things that inventory does in a system that's kind of unstable is it acts as a damper. So, you can imagine in a circuit, it's sort of like a capacitor. It stores energy there, and that cuts down on oscillations in circuits that tend to oscillate or are unstable. Inventory has that same effect. So if suddenly you can't buy some parts from the place that you're normally buying, if you're already sitting on a year's supply, you can use that year's supply of parts to get you through a temporary shortage. And so it tends to cut down on the oscillations of the system, doesn't cause shortages upstream from you, and so forth. But if you eliminate so much inventory from the system, which is the whole philosophy behind just-in-time manufacturing, now you've removed that damping effect. And so when you have something that you're not expecting, that the system isn't built to handle, and we'll talk about that in a second on the semiconductor side, that causes the entire system to oscillate, and you wind up with shortages all over the place, panic buying. And, if you're an academic, it's kind of a great exercise to think about it. If you're sitting as a manufacturer, it's not so much fun, but you wind up with all the things that you've heard about from history, right? gray markets, people hoarding things, prices going through the roof, auctioning things to the highest seller, that sort of stuff. And that's all side effects of shortages in the system. So if you want to talk about, why shortages, what happened in the world when COVID started, and like I said, the whole just-in-time philosophy made things worse when that happened. But one of the things that happened with COVID was in the semiconductor industry. Yeah.
Hey, Scott, I wonder if I could add, is there an alternative to just-in-time? Because if you're not using just-in-time, you're paying for inventory that you're not using. So your dollars are tied up in inventory. It can't be a very efficient use of dollars, especially in maybe in some locations, taxing situations based on the property that you have on hand at the moment.
Mhm.
So you may end your $5 part may end up costing you quite a bit more than that over time if you've got it in stock for a long time. So
Well, it's that
just in time has
flexibility.
a very strong economic
Absolutely.
incentive.
Yeah, because you cannot hire a new employee with inventory, but you can if you have cash on hand, right? You
Mm.
can't move into a new building or upgrade your facility with inventory, but you can if you have cash on hand. So from a corporate standpoint, there's a huge benefit to minimizing the amount of inventory so that you preserve cash. And if
And
you
depending on
can have
depending on that supply chain to supply you when you need it. And then the whole supply chain is kind of built on that principle, being able to deliver things. And everybody along the chain has incentive to not have too much stuff. I mean, the fab making the silicon, I don't know if they make it out of sand or what, but if they don't want to have too much sand on hand, right?
Yeah, and we'll speaking of that, right? So you're talking about a chip, right? Well, the process to make a chip can take up to a year inside a foundry. So you've got to do a heck of a good job forecasting who's going to need how many of this flavor chip a year from now, because once I start making these things, I can't really change course. And that's when I was talking about sort of the length of the supply chain, that 1 year is just one piece of the entire supply chain. So you don't want to sit on huge amounts of inventory. You don't want to tie up your cash for a number of reasons. One, you don't have the cash to do the things you want to do, but what if you've invested in the wrong inventory? If you're an auto manufacturer and you're forecasting, hey, this is going to be a great year for the F-150, so I'm going to stock up and I'm going to fill my entire lot with F-150s. And it turns out that Toyota comes out with a new truck and everybody's going there and nobody wants yours. What are you going to do with all that inventory? You can dump it, you can sell it at a discount or whatever, but either way, doesn't make great business sense to have tied up all of your cash in inventory that's going to get stale. It's not going to be worth as much in the future.
Right.
So yeah, you want cash to be flexible, and inventory is not the answer to that.
And even though electronics doesn't sit there and mold on the shelf like produce would, you still have to, you can't keep a product around for 5-10 years and pay taxes on it every year and hope you'll sell it someday. That's money you've tied up. It's not as critical as, say, a grocery store with, corn on the cob and bananas and especially avocados. You want to sell those before they get ripe, right? So you want them in the customer's hands during that 15-minute time when the avocado is just right, just enough ripe. It's not that critical, but it is critical to
yeah,
okay.
Absolutely. So going back to semiconductors for that's the prime ingredient, right? That's the brains of most of the hardware products that we use in the broadcast industry, and there are a number of things that happen there. So you've got problems on the demand side. That suddenly spiked during COVID, right? So there was a huge demand for consumer electronics with everybody working from home. So laptops, game systems for children who couldn't go out and play anymore, right? All of these things were a massive shift in demand that wasn't foreseen by forecasters when they were deciding which chips to make, right? So there was this massive demand for the chips that go into laptops or gaming systems or whatever. Also on the demand side, right when COVID hit, auto manufacturers canceled orders with chip manufacturers and other people who made the components because there was this massive decline, or at least they forecasted a huge decline in demand for automobiles once COVID hit. People couldn't travel, they couldn't go anywhere, people were losing their jobs, unemployment was going up, right? So they weren't making capital investments in cars. So semiconductor manufacturers saw this huge shift away from automobile electronics and chips that go in there to the chips that go into laptops. So they started this whole process of shifting their manufacturing in that direction. And like I said, it takes a year to change direction, you're not going to be able to move back into the automobile chip manufacturing very quickly. And so we see a shortage in the chips that go into cars right now, the HD radio chips and decoders and so on and so forth. So that's on the demand side, right? So that's what happened in the world of COVID. Demand changed very quickly and by large magnitude. On the supply side, we had all sorts of problems there. So, Kirk, you might have heard about things like the fire at the AKM factory. So AKM is a company that makes upwards of 60% of the chips that go into pro and high-end audio. So A to D converters, D to A converters. They had a massive fire in October of 2020 that suddenly stopped the supply of those chips and caused a big upheaval on the other end of the bullwhip.
So we don't know this brand. AKM is not on the tip of my tongue, but do they make brands? They make chips for other brands like what, Cirrus maybe or other?
No, they displaced
AKM.
Cirrus. AKM, yeah. So for instance, Telos products and as well as many other products, Yamaha mixing consoles, all of these companies that make high-end pro and prosumer audio equipment use their A to D and D to A converters. And then another slightly, what's that?
They make about 60%, you said, of the chips that are
in the very high-end audio. Yeah.
Yeah. The high-end audio, like broadcast gear needs to be, have the best specs available. Okay. Right. And so they had a fire, can't make them. Wow.
Can't make them. Suddenly, word got out, there's a shortage. Everybody started hoarding, buying huge amounts, so that they could stay in supply. They didn't know how long it was going to take before AKM recovered. So people who were normally buying the chips that they needed for their just-in-time manufacturing suddenly were buying inventory to cover what they thought was going to be a long period of time where they wouldn't have the chips. And there was a mad scramble. And if you weren't first at the table for these, you found yourself without a seat, right? So
it sounds like a toilet paper situation.
Exactly. I mean, it's the same effect. So, and then, 6 months later, in March of 2021, there was another factory fire at a company called Renesas, another semiconductor fab in Japan. They make microcontrollers and microprocessors. Again, a lot of the chips that are used in embedded equipment, appliances that you would find in a broadcast facility, for example. So you had those, those were two examples of disruptions in the supply chain on the supply side that caused massive mayhem for our industry in particular. And then in general, let's talk a little bit about fabs if you're interested in that. What is a fab, right? So that's where the chips are made. So, starting 25 years ago, companies that designed semiconductor chips, microprocessors, memory controllers, Ethernet controllers, whatever, A to D converters, they found it was becoming far too expensive to manufacture their own chips. So they became what are called fabless semiconductor companies. And what they did is they found other companies who specialize just in the manufacture of chips. So these are what we call fabs or foundries. So there are a very few number of foundries in the world that actually make chips, but there are hundreds, if not thousands, of companies that design chips, and then they send their design to these fabs, and these fabs under contract make the chips. They make the wafers, they dice them, they put the die in the carriers and sell them on whatever brand, right? Well, it turns out that right now it's about 70% of all integrated circuits are manufactured by two companies, TSMC, or Taiwan Semiconductor Manufacturing Company, and Samsung. So think about that. All of these chips that you're seeing, whether you're buying it from, name a company, Cirrus, Altera, Xilinx, all these companies that you see, that make the chips inside our gear, 70% of all of these electronic chips are actually made by two foundries. So if there are problems at those foundries, or they're limited by capacity because they have a COVID outbreak, people can't come into work, they're shut down for a month, maybe they're running at half capacity for a while, that's going to cause ripples throughout the entire semiconductor industry for months at a time, right? And that's exactly what happened.
So, okay, this is a good pause point right here, but you described several things that caused more than ripples, I mean waves, almost tsunamis in this supply chain. There was COVID, there's fires, of course, people hoarding because the future was uncertain, and of course, consumer demand did fall way off, but then it came up. And I think for the company we work for, Telos Alliance, of course, we were concerned in the middle of it, but then we saw demand come right back up over a few months' time, and demand is really strong now. And then we've seen that happen with other consumer goods as well. So, wow. So after our break, Chris and I are going to talk with you about some decisions that the chip manufacturers have taken that they're not necessarily going to make everything they used to make, because they want to. You know what? It's like a restaurant that had to close down for 3 months, and when they open back up, they're going to look at the menu and say, "Okay, what did we sell the most of? Let's make those things." And the hot pot potatoes with the spinach and leeks, we didn't sell that many of those. So you know what? We're going to quit selling those. And then the customer comes and says, "I want the hot pot potatoes with spinach and leeks." Well, we don't make that anymore. So that's coming up. This Week in Radio Tech, episode 582, is brought to you in part by our friends at Broadcasters General Store and their terrific partner. You know them and I know them. It's Innovonics. Let's hear from Innovonics. We'll be right back.
Hi, this is Gary Lerman. I'm Sales and Marketing Manager from Innovonics. I'm joined here by our President and CEO, Ben Barber, and we're here to tell you about two new products that we're very excited about. They're HD modulation monitors, the model 551 and 552, and Ben's going to take us through some of the features. Ben, what can you tell us about these?
The 551 has the big display, 7-inch touchscreen display. You can look at different parameters instantly by walking up to it and touching it, getting information that you need. It also has the LED displays for FM total modulation, left, right, FM, HD 1, 2, 3, and 4. The other thing that the 551 has is that it has full-time audio outputs on studio hub connectors on the back, both analog as well as AES digital. So you've got FM, HD 1 through 4, they're full-time. The 552 doesn't have the display, doesn't have the metering, and doesn't have the full-time audio outputs, but the web interfaces are identical for remote viewing and monitoring.
Great, thanks very much, Ben. These products are going to be available in January 2022. Contact us at innovonicsbroadcast.com for more information. Thanks very much.
And thanks to... Yes, you're welcome. Thank you. To Broadcasters General Store. Their website is bgs.cc. And you know what I do? I just pick up the phone and call them because they're good folks. You call them at 352-622-7700. 352-622-7700. Look, there's confirmation. There's the phone number in the top of the screen. I've been calling them for years and ordering what I need from Broadcasters General Store. Thanks so much to Innovonics and bgs.cc for sponsoring This Week in Radio Tech. It's Kirk Harnack, Chris Tarr is along, and Scott Stiefel, the new co-CEO of my employer, Telos Alliance. And Scott has been a supply chain expert, whether he wanted to or not. He's become a supply chain expert. Scott, tell you what, give me just a quick aside. We'll put in a little plug for Telos here. We've got a number of full-time people at the company who have done nothing but spend their time, their efforts in getting, by hook or by crook, getting things together to build product. Isn't that right?
Oh yeah, it's all hands on deck here, as you can imagine, right? So, and it's all sorts of problems, right? Chips or commodities that have long lead times, and we need to potentially find alternate sources, or chips, and I guess this is where we're going to go next, chips that are no longer manufactured unexpectedly. Right. So the semiconductor manufacturer, for whatever reason, says, okay, this is end of life. We're not going to do that. And we're put in the position of go first, find the inventory that you can to cover the time it's going to take you to redesign your product around some new chipset there that is hopefully going to be available in plentiful quantities in the future. So we've got everybody from the purchasing department to the operations department. I was working with Greg Shea, our CTO, the other day, looking at various versions of low dropout regulators to make sure that we can continue to manufacture our products, continue to supply to our customers. So, everybody in the company knows that this is not the world we were in 2 years ago, and it might not be as much fun as dreaming up new products, but we're going to do whatever it takes to make our customers happy.
I don't know if you're I don't know how much of the story that you can tell, but we had some part end of life, or it's going to be a long, long time before we could get it again. But we wanted to manufacture the product, and we figured out, hey, we've got I forget what you call the chip. Xilinx makes these chips. What are they called?
Yeah, the field programmable gate arrays, FPGA.
Yes, FPGA. Thank you. We can actually create the signals we were getting from this chip. We can create those in the FPGA with good enough precision to operate the product. So we re-engineered around the fact that a part was no longer available.
And in fact, that part that became unavailable was from the AKM factory. So that's what's called a TCXO, a temperature compensated crystal oscillator. Suddenly, because of the factory fire, lead times went out to a year or more to get some of these oscillators, and the compensation circuit around there. And, our engineers, what is it? The necessity is the mother of invention, I guess.
Oh, yes.
The phrase.
Yes.
And we certainly had a necessity, and our engineers, immediately started experimenting and found a way to replicate the function of that entire TCXO circuit inside the FPGA that was already inside the product itself. So,
and so now Scott Stiefel,
kind of solutions.
So Scott Stiefel, now the new co-CEO, goes around the engineers saying, how many more products have components in them that we don't need?
Yeah, exactly.
All right. So some parts are they've decided to not make anymore, and they're not going to make them anymore, or they're going to have a year lead time. And so manufacturers like us, like other manufacturers, we got to deal with that.
Yeah, absolutely. When you've got limited capacity in a fab and they have to make choices, which chips are we going to use? And they have customers like Apple or Ford, right, who are leaning heavily on them and want to buy millions of chips per year. And, you want to make sure that those customers are happy. And if broadcasters who are talking, hundreds or maybe a couple thousand a year are saying, no, I want my chips, well, guess who's going to win that argument? And so when you've got limited capacity, like we do in these fabs right now, they found themselves in the situation where they had to make hard choices. And so chips that had been around for years that seemed like, hey, everybody uses one of these things, why would they ever discontinue them? Suddenly they're off the market. And that puts companies like Telos and other broadcast equipment manufacturers in the position of saying, all right, if I can't get this chip, I need to find out what chip is replacing that, and I may have to redesign my product, and I may have to work with operations to put units on the shelf while I cover that time period, right? So it's very disruptive to the entire ecosystem or supply chain that takes chips all the way into the hands of the broadcasters themselves.
I want to I want to bring Chris in, and I want to run an idea by you, Chris, to see if you're thinking what I'm thinking. Because Scott just mentioned that they got these chip manufacturers, these fabs get a lot of pressure from companies like Apple, probably from Dell and HP and Asus and people like that, maybe from Supermicro, and from the car manufacturers, right? Toyota and all Ford and all the others. So, Chris, do you think we'll see a day when you buy an audio processor or let's say a mic processor, and you realize that broadcast equipment manufacturers are under pressure to try to use popular components because that's what's available? Maybe the weird, obscure, yet wonderful chip that they used to use isn't available anymore. So you open up your mic processor, you open up, and what's inside? An iPhone.
Right.
Because that's what you can get. No, I'm thinking, or maybe an automatic speed control for a Ford F-150, right? So.
Yeah, right. Well, there's a whole other side to this supply chain thing, which is the end users and how we have to plan as well. Great example of that is with Telos, where I had to order some nodes and a couple of surfaces, and it was about a 4 or 5 month lead time before they came in. We just got them. So it also requires us to think a little farther ahead too. and plan a little farther ahead. Another example is transmission line. It's getting very, as I like to call it, unobtainium. So knowing this, I have a project later this year that normally I would just wait till about a month out and order the cabling. I ordered it now to get it into the system so that hopefully by the time I'm ready, it will have cleared the backlog and be ready to ship. So, it's caused us, first of all, to be a little more creative that way, and also a little more creative in terms of repairing rather than replacing. Now we're looking at, okay, some of this stuff, if we can obviously, some of the parts you can't get, but if you can get a one-off or something like that, or even scavenge from another device, I'm doing a lot more repairing than replacing at the moment. Fortunately, I have a shop that does a lot of my work that, he can pretty much, this guy can fix anything. So, I'm shipping a lot of my stuff there to get repaired. And he's done a really good job of sourcing alternatives. A great example is I sent him an IPA from a broadcast electronics transmitter. Well, he can't get the parts to fix it anymore. But he did find a company that makes amplifier pallets that will work. So he basically completely rebuilt this IPA with new pallets with a totally different design and sent it back. So, it's caused us, to think a little differently too as end users on how we deal with supply chain issues, because we're the last part of that chain. So we have to plan accordingly as well.
Indeed, indeed. Scott, in a few minutes, Scott, we're going to pivot to some newer technologies or newer techniques that may help us out in the long run, or even in the short run, coming up soon. But I want to chat for a second about logistics, about getting stuff from here to there. And I don't know how many Axia X nodes were on that Ever Given ship in the Suez Canal. Maybe you can tell us about how that ship getting stuck in the canal for a few days, how that actually had a huge, bullwhip effect on everything.
Sure. The world is a global place, right? Right now. So supply chains extend to every corner of the world. It's not just in your local area. And, you wonder, okay, so you got this Ever Given ship, right? This massive ship stuck in the Suez Canal. What on earth is that going to have to do with Telos being able to ship a console or some other manufacturer being able to ship whatever it is they make? Well, it turns out, first of all, that ship, the Ever Given, had over 18,000 containers on it. And there's only a fixed number of containers in the world, right? So that, maybe that piece alone, right? Not so much the goods on the ship, but the fact that those containers, which were on their way to somewhere to be emptied and then reused and used in some other supply chain or some other logistics operation, those are now unavailable. The ship itself, what's that?
So companies could say, we've got the stuff to ship, but we don't have the box to put it in.
Yeah, there's a fixed number of containers, and if you disrupt, that's part of the supply chain, packaging, right?
Okay.
Also, blocking the Suez Canal for 6 days. So the Suez Canal, on average, 50 ships traverse that canal every single day. So when the canal is blocked, all of those ships are stuck. They're all lining up. You saw the pictures, right? They were all sitting out in the Red Sea, I guess, getting ready to enter the canal itself. They can't go anywhere. All of those ships, one, they have containers, they have goods that aren't getting to where they're going. But the other thing is the ships themselves. So for instance, if there are chips or chassis or cables or whatever it is that might be manufactured in China or Taiwan or Japan that are destined for the United States to go into a contract manufacturer's facility, they need to use those ships to get there. So if that ship was on its way to the Far East to unload some commodity or whatever and then get reloaded so that it can come to the west coast of the US, and it's sitting in the Suez Canal for a week, that's another week delay, and it extends beyond that, right? So it disrupts the timing in ports. You end up with gluts there. So that's just one small example of how just an incident that took place over a week can have far-reaching effect. And I think the estimates were every day that ship was stuck there, $10 billion in trade was affected. So yeah, it seems like a small problem, a boat stuck on a sandbar, but has far-reaching effects.
Oh my goodness! All right, I'll tell you what, we are going to get to the alternate solution, or where we think the industry's going. But one more thing to talk about. I was just reminded, we have a faithful listener. He's going to be a guest one day here, Tim Braddock. Tim is a broadcast engineer, and Tim brought up the topic of fab, maybe being some fabs going to be built in the U.S., one of them perhaps in Ohio. What can you tell us what you know about that?
Yeah, this is going to be critical. Pete, you're probably reading about this in the paper all the time about, the U.S. government investing in these things. So in addition to the concentration of so many semiconductors with two of the fabs, if you look at where most of the other fabs are, including TSMC and Samsung, they're not in the greatest places on earth if you want stable manufacturing. So for instance, TSMC is headquartered in Taiwan. Taiwan has issues with drought right now, and semiconductor manufacturing depends heavily on large quantities of ultra pure fresh water. Taiwan is also constantly under political threat from China, right? So that's not a good thing if you want a long-term stable place for a manufacturing base. If you look at Samsung, they're in South Korea, where they're bordering North Korea, constantly under threat there, right? Not necessarily the most politically stable place, always a lot of uncertainty. We talked about AKM and Renesas. Both of those are in Japan. Politically very stable, but geologically not so much, right? You've got tsunamis, you've got earthquakes, you've got other things that can happen there. So when you focus all of this manufacturing in those places, and then of course you've got China, huge fabs over there, and with trade wars and the human rights issues and things like that. So the ability to onshore these things that used to be in Silicon Valley, where it got its name, bringing those back into the United States is going to be critical to our future. And like you said, Intel is planning right now a $24 billion investment, and that's just phase one, to build a semiconductor fab just north of Columbus, Ohio. And they're already talking about, if that succeeds and they can get the funding, that could be developed into what they're calling a mega fab, which would be up to $100 billion investment in that facility in Ohio. So that's really exciting. And then in Texas right now, I believe Samsung is also, if they haven't already, they're on the verge of breaking ground on a facility in Texas.
Gotcha. All right. Well, it's time to move on to pivot a bit to a topic that is near and dear to my heart. I've been giving talks about this at NAB and SBE meetings and other stuff for some years, because I do believe in the idea. The implementation sometimes a little difficult. But not every engineer, including myself, has all the knowledge to make this work really well. I'll bet Chris Tarr does. Chris, are you old enough, Chris, to remember the days of reel-to-reel machines and carousels and some kind of programming device to make an automation system?
Oh, sure, yes. Oh, I do,
okay.
yes.
Okay. Carousels, that's a great...
I remember not only the PEG system where you put the little resistors in, but also the numeric keypad, where you'd have to program the entire day's worth of events on the keypad.
Oh, yeah.
So, yeah, I remember all of that. Thank you very much.
And what replaced that, the SMC monstrosity that we had, or whatever brand of automation it was? We had, PCs replaced that. And at first they were kind of clunky, and they may not, the audio may have been 8-bit audio to start out with. And at first it was just commercials, right? And then along came systems that controlled CD players. And then when hard drives got big enough, we put the audio on the hard drives. And then, automation systems on, and that's been around now for 20 plus years at a lot of stations, automation on PCs. Now we're putting automation on PC, but as a virtual machine on a server running other automations, right? So we're getting into that kind of virtualization. Well, what makes sense? And by the way, it's usually not a supply chain problem to get a server, because the world needs a lot of servers. There's a lot of big customers needing servers. So that is a very important, commodity. So we tend to have a lot of those. So of course, what's next? Maybe putting other things into servers, and maybe not as virtual machines. There might be another technology that is more efficient than a virtual machine, because you don't really need solitaire installed on every copy of every automation system you put on a server. Scott, pivot us a bit here and tell us where you think we're going. That we don't have to, companies like Telos still going to make hardware stuff, but now there's a choice for getting a lot of your broadcast functionality accomplished in a different way, Scott?
Yeah, so I mean, there's been this huge confluence of events, right? You have these supply chain problems itself that make it more difficult to build these so-called appliances or specialty items that perform one function by itself. And you've also got one of the side effects of COVID was all of a sudden broadcasters found themselves having to produce content in different ways, right? They couldn't bring 5 or 6 people in for a morning show and have them all sit around a table and talk for 3 hours. So people were doing broadcasts remotely, and that opened all sorts of possibilities in terms of cost savings, right? You start to think about, well, do I really need all this expensive real estate? Could I start to centralize some of the functions here? Could I have an engineer manage more than a small cluster of stations if I had a private cloud where a lot of the audio processing or mixing or telephony functions existed all in one central place? It really makes the mind real. And Telos was already on that path for several years in our R&D department before COVID. This was kind of the vision that we had way back when audio over IP was launched, because it allowed you to decouple from the physical world, because audio is now just packets, and you can have packets wherever you want. They could be, in a cloud. They could be, running around on the internet. They could be on your LAN, but it opens up possibilities. So the idea, the product of most broadcast equipment, right, that does anything in terms of signal processing, whether it's mixing or audio processing or telephony, the brains are actually in the software itself. So you're buying this box, a NX6 or an HX1 hybrid or an Omnia audio processor. You're buying that, but the smarts are actually running inside the chips in there. So in the old days, it might have been specialty DSP chips made by Motorola or Texas Instruments. More modern processors would be running on an x86 processor. Well, once we made that shift and said, hey, we're going to run the software inside the box on an x86 processor, why does the x86 processor have to be in a bespoke box, specially designed just to do this one function? What if we could take that and put it on a different x86 processor that happens to be running in a server? And again, opened up all sorts of possibilities. Now you can have your VX phone system running in a rack mount server, and you might be able to, as a broadcaster, have a relationship with Dell or somebody else and buy your own servers and simply buy the VX software from companies like Telos to do that function, right? So, opens up this world, and that's where Telos has been going. And then the next step beyond having the software application take over the entire server is using things like virtual machines and containers, so you can run multiple applications on one hardware server. So if you think about that, I could have this IQS, which is the software version of a mixing console, running as a container on a server. And on the same server, I could have the VXS, which is the virtual version of the Telos VX phone system, if I need to process calls. And if I don't install it on there. But again, you're talking about commercial off-the-shelf servers, hardwares that are generally more widely available. So it solves multiple problems at that point.
You put that in a way that I really hadn't thought about, but it's a variation on what I've been talking about for years, and that is, instead of, we've been used to buying a box that looks like an audio processor, and it's got meters on it, it's got XLR plugs in the back and some BNC plugs, but inside it's probably running Linux and some software, some code. You're saying that we're moving to a world where we don't depend on a box that looks like an audio processor anymore. That code can run in a off-the-shelf COTS, commercial off-the-shelf piece of hardware, a server hardware, and it can do the same thing. And our interface, instead of being lights on the front, would be a web interface probably. And the audio in and out, thanks to audio over IP, like Livewire or AES67, we got the gazintas and gazoutas. They're just in an IP form, which actually makes them more flexible. We can do more things with them and trade them around more easily. Wow.
Yes. Yeah. Now you're talking about the hardware endpoints. Those will always be there. We live in a physical world, right? So you need something that turns physical sound waves into those packets, right? So you've got your microphone X node or whatever, right? So you're always going to have these endpoints, these touch points with the physical world. But the heavy lifting, the signal processing, that can be all done in software, and it doesn't have to be co-located with where those endpoints are.
Chris, what was your point, Chris?
Yeah, I mean, a good example of that is what I'm doing with Lucy Live, where we went from using Comrex rack mount boxes to off-the-shelf computers for a couple $100, running Lucy software with the Axia drivers. So now, I don't really need all of that physical hardware to do that. I've got the software running on a machine, small, low-powered PC with an Axia driver, and that's it. And it takes the place of rack mount Comrex codecs. So I can totally see this working in the future. And in fact, even with some of the Telos stuff, the software, even though they don't really let you do this, the software is interchangeable with the hardware. So, we were playing around with turning, VX engines into console engines or whatever. So there's really no reason to not look at it that way. And I think, the operating systems and the server hardware side of things have matured enough where it is a commodity thing and they're reliable enough, because honestly, the reason we buy the bespoke hardware is because of the reliability factor. They were built to be in an environment where, we abused them. But servers are getting to the point where, that's also the case. And in fact, have much longer uptime than some of the broadcast stuff we have.
Good point. Hey, it's this has been a great conversation, and I know for a fact that Mr. Stiefel has a tip of the week for us coming up next. And if I can rely on Chris Tarr to have one too, then we got two tips of the week. Okay, good. Coming up, this has just been a great conversation. I'm really enjoying this. Oh, and by the way, Scott mentioned you still got to have some endpoints, and I'll point out that some pieces of equipment, like there's some Nautel transmitters that have a live wire jack on them. So it's possible to get from one piece of equipment into another piece of gear, even a transmitter, without going to, let's say, baseband, without going to an analog baseband connection. So there's a lot of possibilities out there as we move on and as companies implement standards to make things talk to each other. Love it. All right, This Week in Radio Tech is brought to you in part by our friends at Broadcast Bionics and their incredible, clever Camera One system. We'll be right back.
Camera One from Broadcast Bionics. Designed to bring video to your audio content. Visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
I love their equipment, their software, and I love their commercial. And I always feel like such a hick following a guy with that terrific British accent. Nothing compares. I sound like an idiot compared to that ad. All right. Thanks a lot, Broadcast Bionics, for sponsoring This Week in Radio Tech. And you can go to bionic.radio. Yeah, that's a domain. Bionic.radio. That's a
TLD, top level domain, .radio, on the web to find out more. Appreciate it very much, and you're going to love the Camera One system if you try it out. So this week in Radio Tech, we're about to finish up. I'm going to hit Chris Tarr first for a tip of the week, and save the one that I know is pretty slick from Scott Stiefel. So, Chris, what you got for us this week?
All right. So we've been talking a couple of weeks now about the transmitter that I have up in La Crosse, Wisconsin, that had the burnout feed line, which I now fixed. We got that taken care of the other day. But I've been running our programming from an aux site. And what I haven't told people is that I've used this really great device by Innovonics. I'm looking down because I'm looking at it on my phone. It's a Novia 262 made by Innovonics. And what it is it's a processor, but it takes all kinds of inputs, including a stream. So what I did is I set up a shoutcast server back at the radio station, and the processor pulled the audio from the stream, processed it, and then sent it out from the digital output to the transmitter, to the input on the exciter that had the stereo generator and everything else. So what a great little product. I actually had bought these originally as a preprocessor because I was waiting for to get my hands on a compeller. They were back ordered, so these were available. So when I got into this pinch with needing to get this programming on, I poked around in this 262 and saw the streaming device on it, the streaming server, or client rather. And this thing ran for weeks without a burp. I mean, it just was really solid. And it's got a great little processor in it. And, it was just basically a great little utility that saved my bacon.
That is and it's from a sponsor too, so that's great. The Innovonics Novia 262, right?
Yep.
Cool. All right, we'll put a link to that in the show notes if you want to. And that's what I noticed about. I was just looking at the Radio Guide, and you give them a quick mention because they kind of cooperate with This Week in Radio Tech. And there's an ad for the Aaron 650, yet another interesting product. Yeah, Innovonics builds a lot of cool things that solve problems. They'll solve problems that you probably thought there was no solution for, or no easy solution. I actually used an 808 just recently too. Adjust an 808. I had our station owner talking about how the levels are a little bit different between our normal analog audio and the HD. I put one of those in, happier than ever. Timing is perfect, and the audio is perfect. Good deal. All right. Scott Stiefel, you've got an idea that I think is just as clever as can be, but I want to make sure I understand it. So tell us all about it.
So I was, after we talked about this the other day, I was trying to find a way to connect this to our supply chain, right? So pardon me if this seems like a bit of a stretch, but what are we always short of in the world right now, especially, you and I, Kirk, and I'm sure everybody's in the same situation. Time
and toilet paper.
Time. Yeah, exactly. Toilet paper, I'm not going to solve that problem. I'm not going to go there. But I can maybe help you with some time with this tip. So one of the things that happened with, at least at Telos, and I think many companies have done this, with everybody working remotely now, and you stopped these little 1 and 2 minute conversations in the hall to solve problems and, bumping into people and asking their opinion. Everything's all meeting based. So our lives are pretty much governed by our calendars now. Here at Telos, we use Google Calendar, for instance, and you just go from one meeting to another, and you're a slave to your calendar there. And when you've got long-term tasks that require concentration, focus, they need time to yourself. It's hard to find that in between all these meetings. So what I started doing, and here's the tip of the day, right? Make meetings with yourself on the calendar. So what I've started doing, and it's not just simply blocking off time so that people can't schedule meetings on top of that, but actually making a meeting with yourself with an agenda and putting tasks on the calendar at that point so that you can address some of those longer term projects that you want to do. If you're a manager, it's always hard to get to the performance reviews for your people. Put an hour on there, say, meeting with myself to do performance reviews, you block it off, and it's just like any other meeting, and voila, you start to hit some of those larger, I guess, some people might call them rocks, right, in your system. So you're not always just focusing on all the pebbles in your life. You actually start to accomplish some of the rocks that you have that you need to do. So meetings with yourself, with an agenda, blocking off that time and setting goals for yourself. It's certainly worked miracles for me, and I've talked to a couple other people at Telos who've begun to do the same thing, and it's really helped. So that's my tip of the week.
I love meetings with yourself. You said not just block out the time, but put an agenda.
And Scott, this is brilliant. You know, like many people, I've got a stack of papers over here on the things that I'll get to between other stuff. You know, here's part of the stack right here. This is stuff I'm going to get to. You know what? I'm going to make a meeting with myself, and on the agenda will be to address those items.
Perfect.
Man. Chris Tarr, are you still with us? Sometimes Chris has to leave.
I am.
Are you going to make a meeting with yourself?
See, you know, I don't like myself, so I always cancel my own meeting. I get ready and I forget the coffee and the donuts, and
well, if you want to, you can make a meeting with me, and I'll just turn off my camera, and then it'll just be you.
There we
You know,
go.
it's really
I'm sure
special if
that'll
you
work.
make the meeting with yourself in places like Cancun or Paris or the Riviera. You know, so that's the
That's the
next
tip
stage,
right
right? It's
there.
not just the
That's
agenda,
the
but it's the
real
location
tip.
itself. There you go.
Yeah, but
That's
for
the
me to
real
do
tip
that,
right there.
I've got to clear it through some people who are probably going to ask Scott if that's okay, and I got a feeling the answer is going to be no. You can have a meeting at home. Gosh, Scott, thank you for explaining so much of this. I appreciate it. And is there a light at the end of the supply chain tunnel? We're going to struggle with this for months or years till things kind of even
current
out. What do you think?
forecasts, if you look at most economists or people in the semiconductor industry, or even the Wall Street Journal, you know, they're talking end of 2022 at the earliest, potentially first quarter of 2023, till things really visibly start to ease up. So,
all right,
yeah, we're still going to be in this world for another year, and you know, like Chris said, do your planning further and further ahead. Don't get caught unawares, and you know, just understand the context that we're in right now.
Good deal. All right, Scott Stiefel, new co-CEO at Telos Alliance, and still the COO. And thanks very much. Signs 2 paychecks to himself. Isn't that great? That must be.
It's good to be the king. All right. Thank you, gentlemen. It's
Chris Tarr, thank you for being with us as well. I appreciate your questions and input. I really do. Take care.
You too.
Okay. All right. We'll see you later. Thanks to Suncast for producing this episode and every episode of This Week in Radio Tech. And thanks to Andrew Zarian, the founder of the GFQ Network, home of other fine podcasts, and especially if you like pro wrestling, man, he's got your ticket right there. Really proud of Andrew. All right. We got to go. We'll see you next week on This Week in Radio Tech. Bye-bye.